Okay. So the first thing I like to ask about is what have the STEAMettes been up to? And for those that don't know, perhaps, John, could you introduce who the STEAMettes are before telling us what wonders they've been doing this month?
Yeah, the STEAMettes are a group of young ladies, all aged about 11. We've got 5 of them now. Millie is at our meeting. She pops in and out of the view. You can see her ear. But we've got Millie, Caitlin, Alice, and they're joined now by Natalie and hopefully Harmony. Okay, they do lots of STEM stuff. That's why they're called STEAMettes, STEM and art. And recently they have been doing some amateur radio. They communicated with France. I set up an amateur radio call with a French chap in Dunkirk. And if you can do screen share, Matt, I'll show you what they...
I think you can, if you want to share your screen.
Do share screen. Now, where's that then? Oh, yeah, down the bottom, yeah. Okay, so I'll just pull this one up. Okay, get that out of the way. Okay. Share. Okay. Caitlin there. Yeah, can you see Caitlin?
Yes. Is that from Broadstairs?
Pointing towards Dunkirk. That's from Ramsgate, and it's pointing directly to Dunkirk.
Excellent.
Yeah, at the by the boating pool. And
so you didn't have to go down to the.
There.
So you didn't have to go all the way down to Dungeness to do this. You did this from Ramsgate. That's cool.
From Ramsgate, and across the channel there, across the water, is Dunkirk, pointing exactly there. And he could hear us, and we could hear him very clearly with that little 5-watt radio. So all the girls had a go. Let's get Millie up. Let's see if I can pull.
So you did say who they were talking to, and it sounded like a French cat is what I call, but.
Yeah, Robert.
Ah, it was a cat. Sorry.
Yeah. So there's Millie, and we've got Alice as well. So they all had a go. Now Alice's mum is French, so when we struggled a bit, Christine took over in French, and that was all fine. So yeah, building relations with France. So that was one thing they've been doing. They have been sending out a request across the world via a satellite that orbits the Earth, an educational satellite, and they've had a request. They've been requesting people around the world to get them, and they've had a couple of replies. This person here, can you see the screen? Jacob.
Oh, YB8XM.
That's it, yeah. So he responded, and he's in Indonesia. And another chap, Peter in Slovakia, have responded to the girls' request for a card like that. Okay, so that's a message that is being sent out now across the world from a satellite. Okay.
It's the first time I've heard the words educational and satellite in the same phrase. I didn't think educational satellites existed.
Yeah, it's called FunCube. It's only 10 centimeter cubed, and sends signals down to Earth with its temperature and battery voltage and things like that. Okay, the girls have been doing coding with the BBC microBit, and if I pull this up now, this is a 3-page article which the girls have contributed to, and that will appear in a amateur radio magazine.
They're internationally famous, aren't they?
3-page. Well, you say that they're going to be speaking at a conference in America in August about Morse texting. Yeah.
Brilliant.
So we've been making a video about using the BBC microBit, how to code it to send Morse. That's the code. And they did telegraph. Yeah, in this picture you can see the telegraph wire going from Millie to Alice, and they did battleships. So you have to send the coordinates of your missile to see if you can hit HMS Defender with your missile. So you send, for example, D4, send a bomb towards HMS Defender. They made their own Morse key. See the Morse key there? And on the topic of telegraph, down at Dumpton Gap, there's a yellow sign there.
I've seen that.
Yeah, which shows that there's a cable under the sea. And during the Second World War, one of the cable ships got torpedoed. And if you go down to Broadstairs Pavilion, to the harbour there, on the wall there's a plaque to the cable ship alert, because over 50 sailors died in the attack.
Wow.
Millie here is now sending Morse via radio Morse. So signal can travel 100 meters to another BBC microBit, and you can communicate that way. So we've been doing recording for a video. I can show you one of the bloopers. Right, let's just load up now. Come on, that's it.
We like science, technology, engineering, arts, and maths.
Right, so it didn't go too well. But, yeah, I've been doing it properly, and this is proper one. Can you see the whole screen on there? Yeah, here we go. So Millie, Alice, and Caitlin.
We have experimented with converting it into an Arduino with help from Ada Group. It has a built-in compass and it can be used to find the north, which can be useful when tracking satellites such as the FunCube educational satellite.
It has a thermometer unlike Lisa. The BBC microBit version 2 is a brilliant device for children and adults to learn how to code and to learn how to code.
It makes us laugh when the other children in class have no idea what we're saying. If we say a word to each other such as da, dee da da, dit, da. No, I did it wrong.
I see what I'm saying.
Yeah, I cut out the bit that he's got wrong. So there you go.
Well, they're very confident.
Super.
They are. They're incredible.
So, John, what are the if someone wants to become a STEAMette,
Yeah.
what sort of person do they need to be, and where would they go?
Well, it's like Millie, who's there. They need to be intelligent. Is that right, Millie? You intelligent? Yes, that's Mum, is it, or is it Millie? Yeah, we meet at Ramsgate and at the Pie Factory on a Saturday, and we do lots of experiments and fun stuff.
Would you be prepared to drop the "et" bit and become, I don't know,
Oh, it's up to the girls if they want to accept.
maybe at the next general meeting you could discuss that.
Have you got somebody in mind then?
No, I'm just asking the question in case.
Yeah, we can't. Yeah.
Okay. Well, thank you very much for that. More impressive news from the STEAMettes. It's absolutely fantastic. Really, really cool.
Yeah.
John, what were you using for the 100-meter transmission between the microbits?
The microbit's got a radio built in.
I feel like I should have known that, but
yeah. So you code it to send. Well, when the Morse key is pressed, it sends the signal. Yeah.
Well, sends a carrier. Okay.
Yeah. Yeah.
Can it do modulation?
No.
No. Okay. But is it a carrier wave? Okay. Cool.
The carrier. Yeah. So it's a data. Yeah.
Nice one. Thank you.
Yeah. Yeah. When the video is complete, we have to show it on the geekery, and all that sort of thing is explained. Yeah. Okay.
Excellent. Thank you. So yes, thank you to the STEAMettes from Ramsgate. I think I heard there. About 11 years old, and it was really you that are teaching and encouraging them, I think, John, isn't it? The Margate school are hosting a tech club over the summer. It's I'm just looking over there because one of the organisers should be coming here to make an announcement about it. It's not her, but it's on. I think it's on the 27th of July in the Margate school in Margate, and it's a pilot scheme to see if there's any demand for a child-focused tech club day, like a holiday camp centered around technology. And if it's really popular, more will follow. So it's in everyone's interest, I think, anyway, to go there and get involved if they wish. But Genetic Moo are the people that are putting that together, and a few of the people of this that are in this Thanet Technology community are involved as well, including myself doing some tech talks or demos. It's quite experimental, so you can choose what to do. Not too late to get involved either.
Okay. Would they sorry Matt, would they want anyone to sort of let people know about that? Because I mean I still know people at the primary school Pilgrim's Way in Canterbury.
Yeah, I think they would want everyone to know, and all of those people to tell other people as well.
Oh, cool.
It's always difficult to get the word out about these things. There will be an announcement, or is an announcement, on the Margate School webpage. But if Becky manages to get here, she'll be able to tell you roughly the same as that, and hopefully point you to that online version of what I'm trying to say. Okay, oh yeah, someone was suggesting we contact BBC Radio Kent, and sounds like a good idea. I suppose you just phone them up, don't you? I don't know. I'll give it a go. Okay. Now, the most exciting part of the whole evening is the mystery item. So this is an image of the mystery item. I won't tell you what it is until after the talks, but I'll leave this up for a few moments to give you a chance to ponder, maybe ask some questions. If you do know what it is, try and keep it to yourself. Dan asked, is it very, very small? And yes, it is Well, it's all scales, isn't it? You would say what we're seeing here is very, very, very small, but the thing that this makes is surprisingly big within our expectations of what it is. How to answer a question without answering it. A very, very small tablecloth, Lawrence. No, it's not. It is very, very small, and it would be an extremely small tablecloth, but it's nothing to do with tables. Okay. Rebecca's just joined Zoom. Can you hear me, Becky?
I can, yeah. Hi, Matt.
I just did a brief description of that tech club. Becky is the organizer of the tech club in the Margate school. So would you like to talk about it while people consider this mystery item and try and think of some pictures? I'll just try and
yeah, sure. Hi, everyone.
Spotlight myself.
So I'm Becky, and I think I've spoken to some of you before, but I work for the Margate School, and I coordinate their short courses and workshops, and I'm also developing a bigger postgraduate course, which I'll come on to in a minute. But we've got an event on the 24th of July called Tech Club, and it's a pilot drop-in session which is being organised by Genetic Moo. The aspiration is for it to be a monthly event, but for the time being we're just doing a pilot, and we're saying it's a drop-in, safe and welcoming space to explore, learn and play with tech, and it's intended for families to attend with, you know, parents and kids together, so that families are sort of learning about tech together. And the idea is that we'll have a range of different activities that people can get involved with and try out during the day. So that could be interactive artworks, coding, digital painting, electronics, VR, video game creation, and there'll be workshops and demos running throughout the drop-in session. For the demo session, we've got Matt is going to be involved, John Hislop, Nick Thompson and Afra Shemza. But going forwards, well, we're going to use this pilot session to, you know, see how it goes, see how it works within the space, and also to ask the families what they would like to see from Tech Club in the future. We'll then gather the feedback. If it's a popular thing, we will aim to get some funding for it, so that we can provide laptops for kids to use during the events, perhaps those kids who can't afford to have their own laptops, and so that we can put this on a monthly basis and make it free for families to attend. And then we will set it up as a monthly event, and each month there'll be something different to get involved with. So we'll be looking for other tech experts in the area and from further afield who come along and perhaps show something that they know a lot about, or provide a workshop for the kids. So it's on the 24th of July, runs from 1 PM till 4 PM at the Margate School, in the old Woolworths building on Margate High Street. It's free, and people can they can RSVP with a ticket through the Margate School website. But actually, if they just turn up, as long as, you know, the numbers aren't too big in terms of COVID rules at the time, then everybody will be welcome to come in. And I really just wanted to come along and tell you about it, and ask as well whether you would mind sharing the information amongst your networks in case you know of people who might be interested. So I will send some information to Matt and ask Matt if he will share it with all of you, if that's all right, Matt.
Yes, of course. Thank you.
Thank you. And if anyone's got any questions about it, fire away. The other thing that I just wanted to mention as well is that we are launching a postgraduate course in visual communication in October, which might not seem so directly related to tech, but it's intended as a course for people who might want to change career. So if you're fed up of tech and you want to be a designer instead, then
where's the kick out button? How could that happen?
But there is a digital element to the course as well. So I thought, it might be of interest. But that is a course which starts in October and it runs for a year. And it's a postgrad course, but you don't need a degree in a design or art related subject. It can be a degree in any subject or equivalent work experience. And we cover subjects like typography, visual language, image, digital, and human-centered design. And then the students will also be helping to work towards a design festival, which will be running in September 2022. So I just wanted to mention that just in case it's of interest.
Okay. I'll share links to both pages. There's this page about the certificate in visual communication, and I think that's the right page, Becky, if you can see my screen.
Yeah.
And then there's the tech club here. And
right.
I share any links that come up. I do share them in one big sort of easy to get to way afterwards, so you don't have to be scribbling stuff down.
Thank you. I've got we've got a little social media image as well, which I can send you for the tech club, and you could forward that as well. All right. Thank you.
Okay, so Joe, that's a definite double thumbs up for telling primary schools about that.
That would be great.
Yeah, I will do.
Thank you. That would be great.
Okay, thank you very much, Becky.
Okay,
hope bedtime was very good. Thank you, and see you soon.
Yeah, see you soon. Take care.
Bye-bye. Okay, so any more questions about this mystery item that you can see in my screen here before we move gracefully on? I don't know who it's. Joe's asked if it's microscopic in chat. I would say it's nanoscopic. Is that even a word? I don't know. Should be nanoscopic. Yes. Mark Rothko. Someone asked, was it a Mark Rothko? I said no. I thought that was a good bet, but. Okay, you can see a similarity there, but no, it's not a Mark Rothko. Maybe it should be. Anyway, right. Okay, right. Now I'm not going to click anymore. Okay, so the rest of tonight, I'm filling in for the person that unfortunately had to drop out, and it's going to be a little bit off the cuff, but it's based on a course that I ran sometime last year about 3D printing, but also 3D design and 3D scanning. So it's a kind of off-the-shelf talk to give, really. But I'm going to embellish it with a bit of showing you my 3D printing workflow. I've become quite aware that when you get into using some cool new techie sort of toy like a 3D printer, or you just start doing some electronics, it's really difficult things that people don't really know very much about become obvious and not needing any explanation. And I've had a few conversations with people when I've been rattling on about 3D printing, and they've suddenly asked me, what's 3D printing? I'm not suggesting that no one here knows 3D printing, but I think there's something to be said from kind of starting from first principles and maybe testing how I explain how I do things to see if people can improve what I do or maybe learn something from it. So I'm going to sort of kind of race through this the presentation for that course to see if you've got any expert comments on it or any other kind of reactions, really. And once I've done that, we'll possibly have a bit of a comfort break, but the next session of that is I wanted to have a general discussion amongst us all to really figure out what's next for Thanet Technology now that lockdowns have finished and people might not want to be in Zoom calls as much anymore. Maybe we need to do something different. Meeting up physically would be an option, but maybe some workshops or other events, I don't know. But I thought if we all had a bit of a chat about that, some interesting ideas might come out. So really it's what's next for sharing the joy of technology within Thanet communities. Okay. Right, so 3D printing. This course was run over 3 days, and it started from from a foundation of not knowing what 3D printing was, showing some practical uses of it, the different types of 3D printing, the pros and cons, then moving on to really how to design the 3D objects that can be printed successfully. So a couple of tips or hints on what to avoid or what a good 3D print design looks like. And then the third day looked at how to make 3D models of real objects by scanning those objects rather than taking measurements and transferring them manually into a design. And those three things form a really nice workflow for taking almost any object, an actual object that you find or just wish to copy or digitize or use as a start for a 3D printed object, or even things you download but then you want to tweak, all the way through to holding it in your hand. So I tried to cover that whole workflow. Okay, so just go through a bit of etiquette. This is all for when we were meeting and doing the actual course. Yeah, I'm just going to speed through this a bit. So yeah, most manufacturing is subtractive manufacture. You start with a lump of stuff and you chisel bits off it, saw the end off it. You remove unwanted material, leaving what's left behind. And complex objects made in this way often require a bit of assembly because the machines used to subtract that material need access to the block in order to do that removal. So spinning drills, milling machines, or even lathes that spin the item to shave off the unwanted material. But 3D printing is a form of additive manufacturing where you start with a base layer, I suppose, but then you add materials to that. And in the case of 3D printing, I mean, that's really a 2D process that's just repeated layer upon layer. it's like printing on paper and then stacking those pieces of paper up to form the 3D object. And there's even a little video in there. There's quite a lot of different styles of 3D printing. I won't go into those. Some of them have been successful. Some are quite niche and good for particular use cases. But this fused deposition modeling is the sort of manufacturing that we think of, or one of the two really that we think of when it's the mainstream 3D printing, where you get a filament that is fed through a hot nozzle, which is the print head that lays down each layer to sub-millimeter accuracy, like 0.1, 0.2 millimeters. If anyone wants to stop and ask any questions, please do interrupt me. The other popular, sort of almost mainstream type of 3D printing is stereolithography, where you have a bath of gloopy material that, when exposed to different types of light, depending on the material, solidifies. And an image provides the right light in the right place to solidify parts of one layer, and then that layer is moved up to replace it with more gloopy liquid before then selected parts of that are solidified and attached to the previous layers. So it's kind of an upside down gloopier version of the FDM type of 3D printing.
Are there any relative improvements, differences between them? For example, is stereolithography great for making jellies, 3D jellies, out of a material, but whereas one of the other ones is better for making something that's going to be outside in sunlight? Yeah,
so well, I mean, there are differences in the materials that you can use. These resin bath type ones, because the manufacturing process kind of relies on light to solidify the gloop, the resin itself, there's an interaction with light that does affect the finished product as well. There are some models that do better using this a resin printer rather than a 3D printed one. Characters seem to be, like models of characters seem to be better suited to this form of printing. You do get a better surface finish on this. Actually, I just saw a bit of an advancement on this, which kind of grows the shape rather than printing it layer by layer, which has a huge effect on the surface finish, but also it doesn't have layers like other 3D printing does, which changes the mechanical properties of the 3D print hugely. And it speeds the whole thing. I mean, this newish way of 3D printing is beginning to get into the high-end machines to the market, and hopefully will become domesticated or become available to the likes of us in the future. It's 25 to 100 times faster than any other 3D printing, which would be wonderful. You could print some pretty major objects in a few minutes instead of a few hours, which is a bit of an issue with all of these techniques at the moment. So yeah, there's a bit of horses for courses. The resin bath ones are very messy, so not many people can put up with that. So they go for the ordinary, as it were, the FDM style of 3D printing. Okay. Here are some popular ones. I'm going to go over that. And this is the 3D printing process in generic terms. So you start with some kind of digital model. So you can quickly tweak that shape, play around with it without having to get your hands on a chisel or do anything else like that. Once you're happy with the design, you export it to standard file format, which can be imported into lots of different applications that do the function of 3D slicing. And they analyze that 3D object, slice it into the layers, add certain features required for 3D printing, like solid infills are replaced by a material and weight saving lattice, for example. And that produces the instructions that 3D print machines can listen to, G code, in almost probably every case, actually. So the G code that is produced by the 3D slicer can be sent to the 3D printer, which then does its magic and produces the 3D design in the real world using one of thousands of different types of materials that can be 3D printed. But that process isn't a one-off shot, really. It's best when you're in a rapid prototyping sort of environment. So that plastic 3D object is there to give you something to hold in your hand to see if it fits on the thing that it's supposed to fit on, that it feels right when you're using it. And more often than not, holding that object in your hand in the real world makes you realize things that you then go back and change in the computer model, and then reiterate this process a few times until you get it right. And a small example of that is from here. I'll just change to a different camera. Okay, so hope this works. I made this object to as a hook to go on my wall, and you can see it started off like this. The next iteration sort of improved on that a bit. I used a bigger stick so it didn't break off, added this hook to hold it more firmly, and it ended up like this. So you can see the progression of design, and I wouldn't have been able to print this out, hook it on the wall and see that it didn't work very easily without a 3D printer. So this is the iterative process, if you like, that was on the screen just there. Okay. So
quick question.
Yes.
So obviously one of the things with 3D printing is if you're going to make something, you often have to go through many iterations before you get to what you actually want in the end. How, in terms of the plastics, how is 3D printing for recycling? Because obviously, you know, you're going to churn out these lumps of plastic.
Yes.
Are there plastics yet that are recyclable for this process?
Yeah, well, these objects that I just showed you there are made out of PLA, and that's the most common material used by 3D printers at the moment. And that's made out of sugarcane or some other or cornstarch, and it's put through a polymerization process to produce the filament. So it is just made out of vegetables, and they do say it is biodegradable. It's a bit of an edge case, really, I think. If I left this part outside, it would take decades for it to slowly decompose, well, to break down. For this to be decomposed, it needs to be above 60 degrees centigrade, have microbes present. So there's a set of circumstances that need to be in place for PLA to actually decompose. But it's, those conditions don't seem too far away from a compost bin from my point of view. But if you just leave them outside, they won't crumble within a few decades. So sort of compostable. And the other plastics like ABS that are made from oil, they can be recycled. You just turn them into pellets and extrude them back into another type of material. So they're thermoplastics that can be heated up and reused as many times as you like. Then you get into issues around purity. Some of these filaments have got carbon fiber in them now. Some even come with wood fibers, so you can print with a wood effect. It's very difficult to reuse those sorts of plastic unless you want wood effect plastic again. Yeah, it's a very good point, but you can avoid the naughty plastics. Perhaps we should be avoiding the naughty plastics and just using things like PLA.
Yeah, so I mean, one of the things I imagine that in the same way that at the moment, now everyone has a printer at home, over time I expect, it'll be the case where everyone has a 3D printer at home. So hopefully I would hope that, when you buy something, certain elements of it can be replaced and you can just print a part out. But to make that a good thing, there's going to have to be some recycling process there. Otherwise, we're just going to be churning out tons more plastic.
Well, I can absolutely see your point, but also newspapers. Most people read their daily news or watch their daily news now on a phone or a telly or something. It's very rare for people to get newspapers delivered every day. And factoring in the machines that made those newspapers, the paper itself, which might not have been recycled. I mean, chip shops don't use that anymore. The carbon of driving those papers all around the country, if not the world, as well. There's 3D printing could remove a lot of plastic goods from being moved around on lorries. So you wouldn't need packaging. There wouldn't be warehouses full of those items that suffer breakage and loss. It's a kind of a direct point of need creation of these 3D objects. So yeah, hobbyists are doing things like iterative design and that kind of thing, but mainstream 3D printing, it's a bit of a hackneyed, well-worn kind of example, but when your washing machine goes wrong, you can print out the new part there and then instead of getting it flown over from Germany or China or boated over. So there's arguments in all sorts of ways, but I think on the whole, 3D printing and these new technologies are greener. I don't know if anyone would have a different point of view, but yeah, it's debatable.
So I've got a question. If I can step in, Richard here.
Hello, Richard.
So do you see a world in 5 years' time where all manufacturers would issue a G code specification for all of the parts needed to assemble their consumables? Our fridge. I just spent a half an hour molding a plastic fridge tray together that had cracked using some kind of plasticine glue called Subglue, which I can recommend. Yeah,
I know the stuff.
So that's the kind of, every fridge has got a different shaped tray, and you know, and every boiler's got little plastic bits in it, and washing machine, you know, and often they're the bits that go, aren't they? The plastic bits wear out.
Yeah.
So wouldn't it be good if the websites, you know, not only had some diagrams but had G code or whatever the convention is of the future, so that anybody could just print their own?
Yeah, well, there's I mean, injection molding allows you to produce a part millions of times at incredibly low prices because of that economies of scale. You spend 60, 100 grand making a tool, which is totally uneconomic if you want 10, 100, or even 10,000 parts. But if you're going to make 10 million of them, then 3D printing that would take so long and be so expensive that that's not even feasible, let alone economically viable. So it's a bit of a horses for courses thing. There will always be centralized manufacture because of that economies of scale. But there are certain things where being able to email a part for someone to print locally makes a lot of sense. Two ends of the spectrum.
So rather than everybody having one in their home, it might be that you go down to the local store that specializes in that. I don't know, you know, one of the high street stores that's chosen to support that, you know, Argos or somewhere like that, and they offer that as a service.
Yes, that's right. Just like the number of people, the percentage of people with an inkjet printer at home isn't 100% by a long way. But sometimes those people need to print something, the people who don't have them at home, they'll go and use a friend's, they'll use the one at work or at school, or go to a shop and pay a little bit over the odds for that service, but it's a one-off, so it's cheap. And maybe 3D printing will go that same way. You go to your local corner shop and say, can I print this spare part out in white PLA, please?
How many years before we get there, do you think?
Well, I think the technology has come a long way in even the past 4 or 5 years. 4 or 5 years ago, it was very sort of early adopter hobbyist, the sort of person that might have put together a ZX Spectrum from kit sort of form. The machines were difficult to put together, bad instructions, kits from faraway places. Just you needed a lot of passion to get over the initial hurdles. Now you can buy a 3D printer, pull it out the box, download someone else's designs, and immediately get up and running doing some wonderful things. So that hurdles come down a lot, and the prices are beginning to come down, with Argos selling I haven't tried it, but what looks like a pretty good 3D printer for 250 quid. Still quite pricey, but it's maybe in a couple of years' time, given how easy it is to use, the price coming down and it becoming more accessible and more people being aware of it. It might be the number one Christmas present for families to buy in 2 or 3 years, and then it's on the same trajectory as the Furby and all those other famous toys.
And it goes on the curriculum for every school. For kids to learn how to do that 3D print something.
There's a little design. Bit of that's just like the BBC computer and other things. They're given to schools, and the kids that are into that get into that more, but the kids that aren't into that, there aren't enough resources, there isn't enough time to make those kind of niche things available to everyone in a way that would make it mainstream. I think that's really driven by use at home. Really, teachers don't have the capacity, the bandwidth to be able to set up a lesson around 3D printers for everyone. It's just not possible. They have to teach to the whole class, and getting 30 3D printers to work at the moment would be beyond most people.
Yeah.
And it would take the whole lesson just to get that bit going. So
on cost, Matt, where the printers are coming down, but how much were your hooks in terms of the plastic?
the material cost, I think it might have crept into double pence figures.
Really?
For material. I
thought you were going to say
question.
Pounds. So
no,
that's massively different. Okay.
No, and if you don't sit there staring at the wonderful 3D printer doing its thing, time-wise, it's not so bad either. So yes, it's pretty cheap. I couldn't give you a precise figure, but
under £1 for those 3 hooks.
Oh, definitely, yeah. Oh, way under that.
That's good.
And it's been personalised with the Geekery logo. It could say your name, or even your face, or even a 3D copy of you in that. You could have your face sticking out the front of it. It's a very personalisable.
So you mentioned earlier the 2 main types of printing, and then you mentioned a third type where you said you wouldn't have layers. Does this mean there's a sort of equivalent of a dots per inch for 3D printing?
Yes, maybe I'll show you that in the slicer, but that's layer height really. And
sort of sideways dots per inch, if you like.
Dots
per inch per layer.
No, it's a continuous print on each layer. Let me just move forward in this presentation. Oh, there's a loud bit. Somewhere in here, there's a really good example of it's 3D printing a house. So they squirt out concrete. Here it is, and this is like an extreme close-up of the plastic part, but this is actually the wall of a house. But they're just the same thing on different scales. So this is really what a 3D print looks like up close. With a plastic one, the layer height might go down to 0.1 millimeters. 0.2 is the standard sort of balance between quality and speed. But the quality comes from the steps between layers that you can see here. So the thinner the layer, the smaller the step. But within one layer, it's just a continuous splurge.
I suppose I'd expected it to be like almost like a stepper motor, and it would have only been able to go, that the nozzle would have only been able to go to certain coordinates, XY coordinates, but that's not the case.
Well, they are driven by stepper motors, but I think the sort of organic nature of molten plastic kind of overrides that somewhat.
So it kind of smooths it out. Okay. Cool.
Okay. I've completely lost my. Oh, was that me? Oh, it is. Oh, look, there we go. The video. You can see the sort of weird pattern inside the walls. It's like it's internal scaffolding. Anyway, there we go. I'll go back up here. This is quite interesting, actually, about the 3D printing in art, because they say art often leads the way in some ways with technology, where it explores it in ways that aren't immediately thought. I think that is the case with art, but I think it's still at very early stages. So, I mean, in particular fashion, there are people out there doing fashion with 3D printing or additive manufacture. But the stuff I've seen, although impressive, it's sort of like chainmail, really, and it's doing clothes that already exist in slightly new ways rather than inventing a whole new branch of clothing, because you can manufacture it in this way. But there is a book to that sort of thought, really. So this object here is a gear. So you hold the center bit and you can turn the outside. So it's a bit like a bearing. But you can't make this because of the helix thread on all of these cogs. You can't make this in any other way. You have to 3D print it. So this wouldn't have existed without 3D printing. And it's a bit like this kind of shoe, actually, where all of the upper, or pretty much all of the upper, is kind of woven and embedded in the sole. And I do know that there are some shoes that are made by additive processes that couldn't be made in any other ways, with a huge reduction in the number of steps needed to make them. So I think fashion's got a lot more it could do, but it seems to be getting there with additive manufacture. Yeah, some cool stuff in medical areas. But at the beginning of the pandemic, there was a big rush for people with 3D printers to produce face masks for the NHS and that kind of thing. And a wonderful way for everyone to feel like they're helping with that issue. But the 3D printing process, especially with homegrown sort of machines, isn't necessarily a good idea, because most of those headbands that were given to the NHS, if they put them into an autoclave to decontaminate them, they would kind of melt and fester away and kind of mess up the autoclave and need a massive cleanup. The materials and the printing process produce finished products that are porous, and so things get in there, microbes. It's difficult to clean them. They melt chemically or temperature melt because of disinfecting processes. So yeah, it's wonderful because people can rapidly produce designs and email them to each other, but you still have to do that robust engineering and materials science thing in this area. Okay, let me just have a look at the time. Okay, I'm just going to rush through this. This presentation was, I added these bits because I showed this presentation to some classes of children, so I tried to make it a bit relevant to their life. But it's a good point, actually, that a personalization thing makes engineering a lot more fun and more likely to be taken up by kids of all ages, and therefore more likely to be mainstream, perhaps. So being playful with the designs, personalizing them. So maybe 3D printing is going to be the Polaroid of the future, where you take maybe you could scan an entire room as a family portrait and print like a tableau of a particular moment when you're all sat around the table or whatever. Yes, printing Minecraft. That got a lot of oohs and ahs from children still. emailing designs up to space, using the materials available locally, including reusing those materials. So if you need a special tool for one job, you print it according to something that's emailed to you. But then if another job comes up, you just reuse that tool. You turn a screwdriver into a hammer and a hammer into a saw, sort of. So that kind of talks about that use case of 3D printing is really good in some situations, like in space, where you need to be able to print one of a complex thing out every now and again. We're not going to take a manufacturing plant to Mars that just makes one thing. We're going to take manufacturing plants that can make everything. It's a bit like the Minecraft crafting table. Yes, that's the point I've made there. I was quite pleased with that analogy. And this is talking about printing impossible things. It's very difficult, if not impossible, to make a double-ended bolt with a nut on it that actually turns. Yeah. And then I got into 3D. What is 3D modeling? And there's for all of this stuff, there's some amazing tools out there for free, aimed at education, but still really useful professionally. And Tinkercad is definitely one of those. It's a brilliant tool for knocking up a quick shape or adding a fillet to something. And you end up with exactly the same sort of model to print out as you would if you used the big boys like Fusion 360, which has a huge learning curve. And it's very easy to forget how to do simple stuff. But there's lots of, this one's quite cool, still Tinkercad. If you're aware of Scratch, which is used a lot in schools, this is Scratch for 3D modeling, which is a lot of fun. Okay, and yeah, you can export these models to those standard file types that I mentioned before that go into allow it to be 3D printed. Okay. Some design rules. There's some elements of the method of manufacture that mean that it's not great if you have overhangs. You can't 3D print in mid-air. You have to have a previous layer, roughly speaking, to be able to print on. And then the layered nature of it means it's kind of got a grain, so it's very strong in one axis, but it's very weak in another axis, and that's what this diagram here is showing. So yeah, you have to be careful. You have to think about the orientation of layers within your design and how it's printed. But that's the same with all engineering, so manufacturing things. You have to think about your materials and the process used to transform them. And do some stuff. And then this is the scanning thing. Okay, so lots of different ways to scan stuff in. Time of flight, so a thing sends a signal out, a beam of light mostly, or a laser, and it records the time taken for that beam to come back, and it generates a point cloud in 3D space, identifying the surfaces of everything in that space because of the reflected time of flight. A bit like radar works on the same principle with electromagnetic radiation. That's one stage. Structured light, where you shine a grid of light on an object, and as it wraps around the object, it warps that grid away from square, and you can calculate the surface that it's wrapped around. And then there's, well, I was about to say straightforward, a more understandable image analysis, where you take photos of a 3D object from different angles, and software can stitch those together to form a 3D model. They're the three main types of scanning, and they're all very accessible. So that's the time of flight. that is a structured light example. So you can see how the vertical stripes warp around the eyebrow, around the cheek, and then down over the collarbone. So you can kind of feel how that might work for generating a 3D object in the digital world. And yeah, image analysis, it's what they did with back in the Second World War with these strange glasses to be able to have a 3D view of these intelligence photos. And I made a 3D model. I took a few photographs of a skull that's carved in a cliff in Margate, put it through some free software, and it produced this very accurate 3D model point cloud, and so quick and easy. The technology that's available to us for free nowadays is literally magic of 10 years ago or 5 years ago. It's incredible. Oh, this might be a video or something. Yes, it is. So this is the skull, the model of the skull, and it was just, well, I don't know, a couple of dozen photos, and it produced this incredibly high-res model of a portion of the cliff. Astounding. I was so surprised that it came out so well, and it was such an easy process. So that idea of being able to take a snapshot of your family in the Christmas room is probably here if you could get everyone to sit still long enough. Like those Victorian photos where everyone had to sit together. Anyway, so I'll go through how to turn that point cloud into a mesh and then into a file that can be printed. And then I actually went and gave an example of that. Some more examples. And that was it. So that I went on a little bit longer with that, to be honest. So I did think that I would go on and actually show you my sort of an example of a workflow of how I go from modeling through to the slicing through to or maybe I could do that very quickly because I haven't shown you any slicer software, and it's really interesting if you haven't seen 3D printing before, because it really demonstrates what's going on. So I will do that quickly. Okay, so this is some software, slicer software. I think I might need to, yes. Okay, so the first thing you do is bring in let me just find something really good. So I'm just looking for, there we are, yes. So I've just imported a 3D object that I created in Fusion 360. Okay. And I've placed it with the biggest, flattest side down on the plate. So I'm thinking about how it's going to build up the layers and how it might print it. And in particular, this bit here is an overhang. But I'm quite happy with that because it's quite a small angle. So, you know, with a bit of experience, I know that that's going to print. Actually, I've got, yes, I know it's going to print because I've got one here. So you bring in the model, you orient it the way you want it to print, and then up here at the top right, which you can't see because I'm in the way.
Matt,
Yeah.
what stops the model sticking to the plate, the object being printed?
Well, you do want a bit of stick so it stays flat rather than pancaking up at the edges. I don't know what makes it stick. I mean, it's not shiny. It's just achieving the perfect balance between sticky and not sticky.
So you don't need a tool or anything to pick it up off the plate once the item's been printed?
No, and actually it's quite, well, it's a few years since someone invented this, but most beds on a 3D printer, you can pull them off the 3D printer and flex them.
Oh, okay.
Because the plastic cools down and becomes stiffer, so it comes stuck on there, and you just give it a bit of a bend in both directions, and that just pops it off. It's like a bit of buttered bread landing on a tiled floor. It's going to stick a little bit, but if you could sort of bend the tiles, it would sort of peel itself off. Okay, so once you've oriented that, actually, I'll just move myself over there and then come back. Okay. Right up here at the top right, I've no idea if you can read that on your screens, but there are lots of different options, in particular on here, ranging from actually 0.05 millimeter layer height, which it calls ultra detail, which would take about 3 lifetimes to print out, I think, all the way through to 0.3. Is that 6? It is, yes, 6 times bigger layer height, but that's kind of the draft, a lot faster but a lot rougher. So that's kind of the spectrum of choices you get, and what you're doing there is you're telling the slicer tool how to carve up this 3D object. So I'm going to choose 0.2 millimeter quality, just because it's a nice in the middle. Go down to the bottom and then tell the software to analyze the object and produce this, which is the script that the 3D printing machine is going to follow. And you can see, you can kind of rewind and play the individual layers to see exactly what's going to be, what the machine's going to do. So this is the very bottom layer. And then as you works its way up, it's going to print the base plate. But you can see in the top right, there's some letters that I embossed in the surface. So it starts printing those. But also notice when you zoom right in, you can see that the edges are very smoothly printed and, you know, complete build up of layers. And in fact, there's two layers side by side. So you can see there's a yellow and an orange one, and they are the outer shells of the shapes. They need to be the best quality. Inside, no one's ever going to see it. And rather than print a solid chunk of plastic, the slicer, there's an option here called infill that's set to 15%. So this pattern, and there are different algorithms to choose this pattern, but this pattern fills the inside of the base plate just with 15% of plastic. Okay, and yeah, it's a pattern that supports those outer shells, holds them together and stops them squishing in. It's a bit like corrugated cardboard, but in the plastics world. But over here, where the embossed text is, for the reasons of strength, you can see it's gone to 100% infill around these embossed things. And as I slowly work my way up through the layers, you can see that the final 2 layers are 100% infill to get the smooth surface. And so this pink layer is the top of that base plate, or maybe 1 layer away from it. So if I keep going up, yes, so that is the final layer. And then after that, you can see the geekery that curves out of the top of that starts coming in with its own infill, and away we go. And this is exactly what the 3D printer will print. Okay, and I'll just scrub through that one more time from this angle. Quite beautiful. So you can see it's printing in horizontal, two-dimensional planes. And you can see it's reached the extent here. And so these overhangs they're shallow an angle enough that it's not overreaching past the precipice. The limit of that is about 45 degrees. So if this angle was 60 degrees, then the subsequent layers would be stretching out too far and they'll just flop down and you'll end up with a terrible print. And I've got examples of terrible prints all over the place. Yeah, that kind of thing happens where it's kind of drooped because it's not printing on anything. You can get around that sort of length with changing temperatures of the extruder, the temperature at which the plastic's melted and how it cools down. So it is possible to just about print that distance on nothing, because you're kind of building a bridge from between these two uprights when you print, but it didn't quite work out that time. Okay. Anyway, so yeah, this is the last thing I want to really show you about 3D printing. This is a pretty major step. And this is what is turned into G-code, the individual low-level computer language that lots of machines, not just 3D printers, lots of machines understand. Laser cutters, CNC milling machines, lathes, lots of industrial machines. This is an old language, G-code, but it's used to communicate to 3D printing machines. Okay. So I think that's enough from me. So, if anyone's got any questions, please ask.
How long did that take to print, Matt?
At the bottom it says 5.5 hours.
Oh, so that tool can give you an estimate on printing.
Yeah, and it's a pretty accurate estimate, actually. Yeah.
And that was on the 0.3 millimeter.
That was 0.2.
Oh,
0.2 quality. So that is what I did actually print this out. You can kind of see the shininess of the finish, maybe occasionally it glints. But this is about 45 grams of filament, which apparently estimated cost is £1.13.
It's very cool. Can we see the embossed text?
This is version 4 of this. This is the trinket that I give to people who speak at Thanet Technology, and I might have one. No, I don't. But it's it looks like this. But the version 4, I've gone a bit hybrid, and now you get a little laser cut plaque that snaps fit onto some lugs on the corner there.
So the lugs are printed?
Yes, they are.
Yeah.
Yeah. Yeah. And it's, yes. And you can fit more text in there. With the embossed thing, it kind of goes a bit illegible if you make it too small. But laser cutting, you can be a lot more smaller.
The example you gave of the impossible nut and bolt.
Hmm.
How? So I assume, you know, there's two different colours there. So the bolt got printed first, and then the nut was somehow printed around it.
Well,
how did
just
the
like
nut
this
get-
one, just
Yeah.
like this one, it was built up layer by layer. But there are printers out there that can print in multiple colours, not just two. But it's very wasteful. So I'll use this as an example.
Well, I was just thinking that nut moves, doesn't it?
Yeah.
But at some point during the printing process, wouldn't it have had to have been connected to the bolt?
Yes. So,
But was
so
it just a very thin connection that you could just snap or something? Then?
yes, that's it. So if I'll tell you what, I'll show you how that would work. Oops, wrong button. On here. So okay. So if I'd gone a bit crazy and really messed up my print, I'd say I want you to print this at that angle. Okay, and hopefully it's obvious that you've got a really bad overhang here.
Yeah.
But you know, it might be necessary to do stuff like that from time to time. But you can tell the slicer to take that into account. So I've put it at that weird angle, and I've turned on something called supports, and that goes away and it builds a scaffolding underneath the print where it needs to, and that's what that light green area is there. But it prints it with a very light touch kind of connection to the actual print, so you can just snap it off and leave. It does scar it a little bit underneath, but not as much as you would think. So you can see it's a very open, airy kind of print, very weak and very snappable, but plenty of strength to support the actual layers the way you do want a good finish.
Do you then? Is it common to sand down something that's been 3D printed?
Yeah, you can do that. Some people put it in a small tank with acetone in it, and that chemically kind of melts the surface. Some people have played around with baking them in an oven, but that's not very good. Sanding is, or spray painting them to get a smooth finish is a good way too. But yes, it's just like any material. You can go back to the subtractive old world and sand and polish to whatever finish you need if you have the time and patience and need. I don't know why that came up, but it did. I can't remember why. Why did that? Why was I talking?
I was asking about the nut on the.
Yes. Oh, yes. So the nut would effectively have a little bit. Would have scaffolding underneath it to allow it to start printing, and there would, and maybe that would support it
during the print and
around the bolt,
allow you to keep it away from the.
Yeah,
from the bolt.
either completely away, or it would have a very tenuous connection to it, like these scaffolding examples here.
I asked a question about a Klein bottle. Could you print a Klein, like a theoretically impossible 4D whatever it is object? And I guess you can, because you can make a Klein bottle. Therefore, you can...
Yeah, there's many examples of otherwise impossible to make objects, and some really interesting things where a single print pair of pliers, where it uses it uses a structure that has kind of, there are no moving parts as such, there are just warping parts. So a hinge becomes a piece of plastic that just flexes, a spring becomes that same piece, and it's sort of opening up a really interesting area of design.
It would be lovely to think that car manufacturers let you do it, but I guess that they wouldn't sell spare parts if you yeah, and that's how they make a lot of their money.
Yeah, but they can't stop us making copies of their parts, but
Copyright.
Their parts are more complicated than a lump of plastic. You've got to get metal bits in there often, or foam, and yeah. So we're not replacing the parts bin yet, but in some areas, yeah.
Does stuff like copyright apply to this sort of stuff?
Yes, it does. Yes, absolutely. So I couldn't copy a Coke bottle and sell it as a design on the Thingiverse or something like that, because it's not my design. But if I got a Coke bottle and made a copy of it and used it, there's no, I doubt if they would even notice. But if they, I don't know. Don't know actually. Would I be in trouble if I was if I was famous? If I was Ronaldo and I wandered onto the press conference with my own 3D printed Coke bottle but with Fanta in it, I don't know. Would I get into trouble? Not sure. It's a good question.
There was a video on. There was a particularly sort of nasty case at the start of lockdown, wasn't there, where a lot of ventilators in Italy were out of action due to a little valve being unavailable, a little diaphragm for the valve, and someone created a design file so they could be made, and initially the manufacturer went after them to stop these being made, because I seem to remember in the end the PR backlash against that meant that they did in the end release the files.
I've got an image of that. I think if you could, it's that one on the top left, just underneath me here. That's the item that was 3D printed in Italy by that guy. I've got a link to that actually. So it's really fascinating how that all developed. How they did get into trouble with the manufacturers, but they relented. But there are drawbacks with it because it is 3D printed. It's not as good as the actual thing. But in that situation, it was good because time was of the essence, so and quality suffered, but that was good enough.
Yeah.
Can you read the text on this?
No.
Well, there they are. Yes, normally it cost 11 grand to make one of those, I think it said.
No, anyway. You're making them for $1.
So yeah, that's a really interesting story. But with all technology, it doesn't exist in a vacuum of technology. It exists in the world of economics and disease and fashion and competition, and that is a particularly interesting story, how the normal rules didn't apply.
So Matt, if you do another one of these talks, it'd be another time. I'd quite like to see the demo of Tinkercad's Scratch-like language. I think that would be quite cool just to see. So I'm hoping it will sort of remind me of Logo from when I was a kid.
It will, I'm pretty sure. Logo plus.
Yeah, Logo 3D.
Matt, have you done anything with sort of a hybrid approaches of 3D printing a mold and then using that to cast, or as a former for to then, I don't know, vacuum cast?
I haven't personally, but I'm aware of people. You can print in rubber-like materials, so you can make rubbery wheels and you can make molds that you can bend a certain amount to let casts out. I know the US Air Force and the RAF and quite possibly some other air forces, they use 3D prints to form aircraft skin. So you get a flat bit of metal, but you need to turn it into a curved bit of metal with a weird bulge in it. And rather than keep a whole warehouse full of all the possible bulges and whatnots, they just print the bulge out when they need it and hammer the metal around it, and off they go. So that's a bit hybrid there, isn't it?
For making parts on a ship, you'd imagine it's pretty cool. So you're miles away from anything. You need some spare part. You don't have to wait until you get to the port. You make one.
Yeah, and in the medical world, they print structures around which bone can grow, but over a shorter time, a suitable length of time. That structure then melts away, just leaving the bone behind. And they grow cartilage over similar things as well. In a petri glass, a petri dish. Sorry.
Well done, Matt. That was really good.
Yeah, thank you.
I like that. Yeah.
Okay, thank you very much.
Just want to come and have a go now. So
very good. I hope you're going to print yourself a trophy, sir.
Oh, yeah. I was thinking about that, and yeah, it takes 5.5 hours. You know, it's a lot easier now that I can just laser cut this, so I can just have this printing the same plastic bit over and over again, and the personalization just is a lot easier this way. So maybe I will do my own.
How what's the maximum footprint you could do? Like, could you do a couple of the
yeah, I could probably fit 6 of them on there at once. I'm not quite comfortable leaving it printing overnight, and I'm not staying here for 30 hours.
Yeah. Is it the sort of thing that can be paused and then?
Yeah, you can pause them and it does start again where you left off. So that is a thing. Yeah, it's a good point. Maybe I should do that. That would relieve some thinking time, wouldn't it? Yeah, thank you.
It's really good. Really good.
So what I would normally say after someone else finished talking is that we could still do rounds of applause over Zoom, but it sounds a bit beggy when I say it about myself. So
you know, we could do a round of applause. Since he did ask.
Spontaneous, thank you.
Did I miss the answer to the quiz?
No, that's coming up.
Oh, good. Okay. Because I had to pop out for my pizza was ready.
Okay.
Matt, are you going to put your slides on? Send them out.
Yeah. Oh, and there is something else actually that I'll put in there as well. I'll just show you it on screen. So I'll send a link to those PowerPoint slides, and well, it'll be it will include this here. So this is an online thing. If you've got the link, you'll be able to get to it, and it just lays out the syllabus of that course and lots of links to stuff. So more detail behind the slides, and I do update it from time to time with more links and stuff like that. So I'll include that in this. Okay. And actually, I'll show you a Thanet Technology thing. So as well, I put the videos on YouTube, but I've also been putting all of the information from every Thanet Technology meetup in this file here. So there are links to every mystery item that we've done so far, links to a page of tabs that talk about everything that we've done, and the Zoom recordings on YouTube are linked to it. So this is a good sort of one-stop shop for anything, any material that we've covered in the past, including Lawrence's talk back in April, all of John's STEAMette updates.
Very impressive, that.
So that's there too. Okay. Now, after this, I wanted to just talk about what's next for Thanet Technology, because I'm always questioning if Zoom is the only thing, the only way we can do things. You know, what do other events that you're aware of? What are they doing? Are they going all the way back to physical meetups again? Are they staying with Zoom, or is there something in between? Should Thanet Technology start doing workshops for people again, or do we want to do a Raspberry Jam? Lots of questions like that. So I just mentioned that so you can start thinking about. Bye-bye, Lawrence. You know, what you would like to see from Thanet Technology and how could we do it. But before we talk about it, we should do the mystery. I can't believe Lawrence left before finding out what the mystery object was. I think maybe he thought he knew what it was. Okay. Right, so just to recap, this is the mystery object. Does anyone have any other questions before we go to the big reveal?
No.
Okay. Well, the answer is it's a field programmable gate array. Does anyone know what that is?
No.
Yes.
I can see it. So I haven't got Zoom window on the top. I saw someone's ear nodding, but so Dan, you were nodding.
So
Does everyone know?
It's like programmable discrete logic. You could think of it, but you can do loads of stuff with them. People have essentially built chips that are essentially copied processors and implemented them as FPGAs.
FPGAs I've heard of. It's me thinking it's something to do with the field.
Yeah, it is an incredibly flexible chip where you it has hundreds of thousands of logic blocks in them, and those blocks, they used to be just like NAND gates, but now they're a bit more complicated with flip-flops and logic gates and lookup tables and all sorts of stuff in each of these blocks, but they can all be connected to each other in almost infinite ways. And there's a load of in-out buffers around the edges of that. So these are massive, complicated chips that don't do anything at all until you configure them and tell them these logic gates all connect in these ways and they interconnect in these other ways. And you can put any computable problem, any digitally computable problem on one of these chips, and then you can change the chip to do a different problem and then another one.
They're reprogrammable. Oh, okay.
Yeah, yes they are.
Wow.
And that's what that flash memory stuff up there does. So you kind of code hardware, you're kind of coding a chip. But you could make your own Arduino in an FPGA. You could do an LED, a controller for thousands of LEDs. You can. It's incredibly flexible. So brilliant.
You could also just make a counter or something like that.
Yeah. A doorbell ringer.
Yeah, just something really basic, just to start you off. It doesn't have to be huge.
Absolutely.
One of the bits I remember from university, I went to Brunel, and the computer science stuff was more high level, but I was able to do a couple of courses from the electronic engineering department, and they were getting into full-on logic circuitry. And I remember building, or just not building, but actually just designing adders with transistors and FETs and stuff like that. And so it would be quite interesting to just implement an adder, just for no reason. It's not needed, but
just to know how it works,
just to prove you can. Yeah. Well, I think people do that with Minecraft now. I think with Redstone now, and that sort of stuff. So maybe I'll skip the FPGA and go straight to Minecraft.
Oh, you should be so lucky. So, if you want to know more about FPGAs, this EEV blog, which you may have come across, once you get over his slightly annoying squeaky Australian voice, he knows his stuff inside out, and he explains things very well. And he's got a great 37 and a bit minute video about what FPGAs are, and the advantages and disadvantages. I mean, they are incredibly flexible, but they're also incredibly expensive, hundreds of thousands of pounds for the really high-end ones. But I've seen them being used in defense applications. They're used in medical applications as well. You can get high levels of security in them. So if you want to do anything really that you want to keep secret, FPGAs are pretty good for that. You don't have to send them to Taiwan to be manufactured for a start. You can just write the code and keep it to yourself, buy the hardware and flash it to do whatever you want.
Does this mean they're sort of analogous to 3D printers for manufacturing? Is that why you chose it?
No, I chose it because of a sort of a makey sort of friend of mine who went off to do a PhD in this area. He started doing a course on how to design FPGAs, and that's where I got that image from. So that image is of the homework of one of his students. So you write it in a high-level design language, but it's still extremely complicated and very easy to stuff up. But the advantages are so awesome because you can do like thousands and millions of operations all in parallel. So people are using them for like kind of bespoke chips tailored to very specific tasks in artificial intelligence and machine learning, image processing, lots of things like that. They're incredibly specialized chips to do things incredibly fast and thousands of times all at the same time, which is great for neural networks and machine learning.
Sounds like a great thing to have on that spacecraft alongside the 3D printer.
Yeah, absolutely right. Yes, you can send up different chips to the same hardware. But as well as this buddy of mine doing a course on it, I also got this thing here, which is, I found out after buying it. So this is a little kind of it's a USB oscilloscope, and oscilloscopes need to do things really, really fast to be able to get the waveforms, like 40 megahertz type thing, so reasonably fast. So they used an FPGA for that, but it's so powerful that it does as well as being an oscilloscope, it can be a waveform generator, a power source, a network analyzer, and a handful of other things at the same time. It's astounding how, I mean, most of this is the connector, but this just this bit here, and then that's the palm of my hand. That is all of those things. There's a big list of what it can do here. So it's a dual channel oscilloscope, a dual channel waveform generator, network analyzer, spectrum analyzer, a voltmeter, can be a power supply, a logic and bus analyzer, a pattern generator, discrete IOs, and it's got a headphone and speaker jack as well, just for good measure. It's unbelievable, and that would cost tens of thousands of pounds a few years ago, and trust me, that did not. I do not have the money for that kind of stuff. And it's just amazing, amazing technologies. It's magic, and FPGAs allow that to happen.
Is that a fan on the back? It's difficult.
Sorry?
Is that a fan on the back, or is that a?
No, there's no fan.
Yeah, okay, yeah, it was just the way the light caught it. Yeah.
No, there's no fan. Oh, blimey. That sends a shiver down the spine. The toys that we've got to play with nowadays, and what we could do with
How
them.
much is that device, Matt?
That was £400,
Okay,
but that's with extras like the BNC connectors and the probes and stuff. It's less than £400 for that box that does all that cool stuff. It's amazing.
Still amazing. But yeah, I remember when I were a lad, there was a spectral analyzer that was basically the cost of a house.
Yeah.
Essentially, you could buy a very, a half decent semi-detached house somewhere with the same amount of money.
Wow. I can't remember where I bought it from. I'll just go to file now. I'm having to relearn how to use an oscilloscope. It's amazing how quickly you forget everything.
I remember there was one of the Raspberry Pints in London. Somebody from Surrey were talking about an FPGA programmer on a Raspberry Pi.
Oh no, I can't remember that one.
I seem to remember that. It might have been shortly after you left us, but I seem to remember. I seem to remember it was at that pub, that one in Elephant Castle. I seem to remember them being there. So yeah, very cool. I have to say.
Where did we used to meet up in? We used to meet
near London Bridge.
Yes.
Yeah, I've got the name of the pub now.
The Miller.
The Miller, thank you.
Next to the hospital.
That's it. Yeah.
Yeah, I missed those days.
There. Yeah, same here. Yeah. I think they were based in Surrey.
I can't remember that particular talk, and I wasn't organised when I did the Raspberry Pint, and I didn't record anything. I barely remember to turn up sometimes, to be honest.
Nonsense. Superb they were.
I do remember having to meet on a pool table because we were double booked.
Yeah. Out in the rain, I think.
Yeah, that was another one.
I'm going to have to shoot off in a moment, so I just wondered if I could put my 2 cents in on the future. Basically, I want both. I want to do the Zoom meetups, and I want to do the in-person meetups as well. So, don't quite know how to resolve that one. Maybe a mixture of events, and workshops at the Geek Crew would be fantastic as well. So that's 3 things I want.
Well, I'm in sunny Tooting, so it'd be a bit of an ask to pop over to Margate, although it would be lovely too, I have to say.
Be a nice long weekend.
Yeah.
So having some Zoom meetups would allow more people to attend.
Yeah, well, I think you out-of-towners bring a lot to these meetups, and I'd be loath to lose
You won't lose us.
the Tootings, the Dovers, and the Southends, and even the Birchingtons and Ramsgates if we have them in Margate. That's quite a schlep on any Thursday evening. So,
let's compromise. Let's go to Westgate on Sea.
Some self-interest there, I think.
Yeah, maybe.
Some things will work on Zoom, like talks will work with a PowerPoint. Some things, like if you're sitting there doing some 3D printing and you're literally watching it happen, and there's, if you plug in electronics, we do electronics with the Essex STEAMettes, and it's quite hard, you know. Oh, it doesn't work. If I plugged it in the right, it's got like a really tiny wire. we just about do, but it's, yeah, in person it's going to be a lot easier. And just as another thing which we kind of mentioned before, given that we are now in the 21st century doing Zoom and that kind of stuff, so I spoke to John about the Kent STEAMettes and the Essex STEAMettes doing a cross estuary amateur radio and potentially stuff over the internet, MQTT, and getting the adults involved. So, and not just in Kent or Essex, but, you know, they could be anywhere with MQTT and the internet and Zoom. And so I've got a little Python thing where you can send and receive, and that's a real basic hello world that I've just got from the MQTT documents and made a little bit simpler. But then as enthusiasts or professionals, we can then plug that into more exciting things, and then, you know, the young people can see something which is really cool that maybe someone who's a lot more experience has done, but also then send you some messages and control it. So I know some people have done robots over the internet, over Zoom, and you send messages. So something similar to that, but, you know, you could, I've got my AstroPi here and my Sense hat, and I'm going to show them. The Essex STEAMettes are meeting up for the first time. It's got a humidity sensor. I'm going to show them, if you blow on it, and as the humidity goes up, put all the lights up. So we're going to have a little competition.
Very nice.
And that's a lot of fun, but that'll be in person. Now, we've done that previously. It's a lot of fun. It's quite cool. But those humidity sensors could be sent over to, well, sent to a central server, and you could all subscribe to it. And then, you know, what you do with my humidity readings as I blow it, it could change, you know, if you've got like a musical instrument, or if you've got some coloured lights, LEDs, near pixels, they could change colours or flash, or you know, change your musical instrument tones or notes or whatever. Or maybe you've got a little robot arm, and the robot arm could move up and down as I blow on mine. So harking back to Andy Stanford Clark and the other chap who was talking about the Internet of Art things. So that's kind of, you know, doing it at an easy level for young people to learn, and then they can interact with stuff that we may do at, you know, at a kind of a more advanced enthusiast or possibly industry level.
Yeah.
So just keeping what we've got from the pandemic, and, you know, keeping our 21st century Zoom skills and things like that. So
yeah. Well, it would be it would be also good to look at having a shared repository, some kind of GitHub repository for the code. So rather than recreate the same software, you can have a central core that constantly grows and gets bigger, and make that accessible to groups like the STEAMettes.
Yeah, you can create a GitHub organization, can't you, which has lots of different projects in. So yeah, that's a good idea.
So you could get the industry pros to fork their code and add bits to it to show where it could go, where their code could go, perhaps. That'd be quite interesting.
So would it work at those sorts of workshops where it's in person but at different hubs, and then the hubs are linked, so you can say, right, we're sending some messages, and the other party shows you what's happening in response to the MQTT?
It feels like the best way to keep the best of Zoom but get the best of personal meetups, there needs to be a bit of experimentation to find out what's the best way, and maybe it's a seasonal thing, or maybe it's a subject-based thing, or, you know, turn up and down the hybridness depending on what the subject is or what situation you're in.
That's true. I remember back my amateur radio days, John might have to give me his opinion on this, but it did seem to be that amateur radio got more popular in the winter, I guess, when everyone was sort of home. And then so just doing their stuff. In the summer, you could actually go out and just see the other people. But yeah, in the winter.
Well, I suppose we've just had an 18-month winter, sort of, where everyone's been at home. So Zoom has been very popular, but we're going to bounce back a bit the other way, maybe.
Yeah, I mean, this Saturday, the Essex STEAMettes are having their first meetup since lockdown, and most of them have joined. So I think only one of the 8's actually been to one of our in-person events before pandemic. But what I was thinking, because we're going to have, if we've got 8 girls and 8 parents, then if we split them up onto 2 tables, so 4 people at each end of the table times 4, that would be 16 people. I thought we could actually have Zoom and do a screen share, and that would actually be easier for me to show them. So I was going to show them Tinkercad and then get them to do things, but I don't actually have a projector just because of the layout of where we are on a Saturday. So to actually show them on Zoom, and then, you know, our Scottish STEAMettes can possibly take part. I'm not sure how much fun that'll be, but that actually works quite well when we're remote. But I was thinking possibly, you know, set up a Zoom meeting, so when we're in person, because obviously we can't walk around and be as flexible because we've still got social distancing for the next month or so.
But I mean, it is a really good point. You could do Zoom in a room, because you can
Zoom in a room. I like that.
you can use your phone as the camera, so you can get close-ups on the stuff that you couldn't really do on a projector, even, or, you know, projecting from a laptop. So it's not just the Zoom thing. It's the being able to connect devices to that Zoom room as well.
Jitsi Meet, Jitsi and the free Jitsi Meet is actually a little bit better than Zoom, because everybody can share their screen. So the way Matt was doing he's doing it now, actually. I think, was it OBS you're using?
Yes.
Yeah, so we could all have our desktop here, and I could look at John's code, and I could look at Dan's, and I could look at Paul's and Richard's and Matt. And there's no, we're going to do a screen share, because everyone's simultaneously screen sharing it at the same time. And then that way I could, you know, just sit here, look at what everyone's doing, see them working or not working. And, you know, I could say, oh yeah, oh John, you got a little mistake there. Oh, Dan, you're doing well. And, oh, Richard, you've not moved for 20 minutes. What's happened? So,
what was that software that you would use?
So that was Jitsi. So Jitsi's like Zoom, but it's a free and open source one. Unfortunately, it's really heavy on the CPU. So the Essex STEAMettes, a lot of them just spent so much time rebooting their computer and, you know, getting their computer locked up, that like Zoom works so much better. Yeah, Jitsi. It's good if you got a fast computer.
A good excuse if you want to buy if you're looking for an excuse too. But Jitsi.
Yeah, so Jitsi Meet is the free one. I mean, we could do it now if you want. We could, you know, if you go up to Jitsi Meet.
Well, I'm going to dash off, gents, but thank you very much.
Cheers, Dan.
I look forward to how we do this.
See you at another Zoom, Dan.
Yes, another Zoom, definitely.
Probably won't make it to Margate.
Night, everyone. Bye-bye.
Right.
Bye.
Yeah, if you want, we could, you know, we could do it now if you want. You can set up, see where it says start and join meetings for free, no account needed. If you just click that blue thing, start meeting, it's that easy. And if you've got a new meeting, you can put that link into the Zoom chat, There we go. So, and then you probably won't be able to share your camera. Well, we probably won't. You've got to
Yeah.
there. So if you give us that link, we can then join it in our web browser.
Okay, digital password suspect first. Is that the link?
Yeah, so they're just random. They're randomly generated. And if you put that URL in, yeah, you don't need to install them.
Can you see the?
If you copy that meetjitsi.com
Oh,
where it
up
says,
here.
put that
Okay.
in the Zoom chat. We might get some echoes if you. So if your browser can turn off sound in your browser.
In the Jitsi tab.
Yeah. Yeah, so if you just go up to that URL,
Andrew,
give us that
hello.
URL, and
I'm trying to kill my sound. Hang on.
Wow, Zoom alternative.
I know somebody who runs a thing using a thing called WonderMe, which is also free, and it's sort of like a pub, and you kind of move a little persona next to somebody, and you can talk to them. So it's WOND, WonderMe. Yeah, that might be it. That's quite good. Also free. You distribute a link. Somebody lets you into their club. That's quite cool too. And there's another one called High Fidelity, which is somewhat similar, but the sound is better, as you might imagine.
I think that I went. There was I can't remember the name of the tool now. Remo. I'll never be able to remember it. Oh, maybe it's that one. Maybe it's just remote. No, it's quite a busy market, this remote working thing. Maybe that is that it? Remote. I can't remember. Interesting. Yes, I will look into those two.
I'll hang up. What's that?
And it's interesting doing it locally within a room as well, Andy, as you were saying.
Yeah.
How you can do the local meetups better with these things in the room, because you can see what people are doing on their computers instead of constantly wandering around looking over people's shoulders.
Very cool.
I am hoping that people will be desperate to meet up as well, so that will swell the numbers of people that come to any meetup. Just like Zoom has allowed more people to come to these meetups, maybe not having been able to meet up physically for so long will also swell the physical meetups too. I don't know.
I mean, one thing which does work quite well on Zoom, if you had a few more people, who's doing the breakout rooms. So I know, Matt, you're kind of running it, and it's mostly Matt. And when I run mine with the STEAMettes, it's mostly talking via me, but then we do breakout rooms, and they quite enjoy going off and doing breakout rooms on their own. And so not as many meetups, like this, or my adult meetups actually do the little breakout rooms, but they are quite fun. And
I haven't really used a breakout room. How are they different from just leaving a Zoom call and starting another one?
Well, it's basically it flashes in your face so you know what's happening, but then you will be in a room where there's like only 3 people or 4 people. So yeah. So I say they like it because I'm not there, and you know they can talk about whatever they want and you know talk freely. But it might be that we have a talk about, you know, maybe John and I talk about Essex STEAMettes and Kent STEAMettes, and maybe someone else talks about 3D printing, and someone else talks about stuff that's they're doing physically in Margate, and you know perhaps you're meeting up or something. So you different topics.
But you can you drag people back into the main room?
Yeah.
At your command, kind of thing.
They sort of have a countdown time. The ones I've attended, they kind of time you. You know, the breakout rooms are finishing in 10, 9, and then you're all back in the room again, sort of thing.
Okay, yeah, very useful.
And that one to me is quite good because it's just like being in a pub, actually, in that you can all cycle around a table and wander away to somebody else who's talking. You know, you can have a table for microBit and another one for FPGA, and if somebody's interested in one or the other, they can wander over. But it's quite cool. So.
Yeah, I think someone ran a mini conference and something very similar to that, where you could walk to different tables and there were common areas and that sort of thing. So a bit more of a graphical story about the place than some kind of conceptual rooms in the background somewhere.
I have to say, I am one of these people who found Zooms, they're okay one-to-one, but the moment there's a group of people talking, it's it's to the exclusion of everyone else, sort of thing, and it feels that's the thing that breaks them, which is why I prefer one-to-me, because you can basically talk to the person next to you or move away and talk, sort of thing. So yeah.
What's also quite good with remote meetings is where taking that move away step one step further, where the sound actually reduces. So that
does it in one-to-me. It does it, and in fact you've got like a nose, so you can face one person who's talking.
Yeah.
And then turn around and they kind of dim out, and you can talk to you can listen to the person, and without moving, you can sort of face who you're facing. I can't remember if it was one-to-me or High Fidelity. One of them, the phase changed and all that sort of thing. So you really got the idea you were, in front of somebody or behind or to the right or to the left.
Yeah.
Really
This sounds like Joe Brunton's world of expertise here, who's on this call.
It was pretty cool. I think it's called High Fidelity, very similar to one-to-me. Yeah.
Do you want to tell us what your thing is, Joe?
Yeah, sure. Do you mind if I grab the lights? I've realised it's got really dark. Is this about the moving?
Yeah, the app.
Yeah, so it was for my uni project actually, but I played 2 songs at the same time, and then I move my phone, and it takes the heading from my phone and fades the volume out of each one depending on whether you're facing north or south. You hear 2 different. So it could be. I mean, it could be used, just like a DJ would mix their decks between 2 different things. But I used it sort of more creatively for my degree to sort of change the instrumentation of a song, and yeah.
Okay, cool.
What were the components of the songs?
Well, I did a few different examples, but a really good way of demonstrating it was by just taking apart the song. So you could put the drums at north, and the keyboard at south, and the voice at west.
So you were just mixing wave files, were you?
Oh yes, yeah.
So
It wasn't triggering anything.
Yeah.
So if you're in the middle of all four, you heard all of them, and if you move towards the drums, you heard the drums, for example. That's all.
Yeah.
Okay.
Yeah, it only worked on on a circle, so it wasn't dependent on like your physical location. But
I see what you're saying. Okay.
Yeah.
Well, not yet. Maybe that's
not yet. Yeah, there you go. There's the 2.0 version.
You could paint a town with a virtual soundscape that you've walked through.
That would be a very cool idea. Yeah. Where were you when I was writing my dissertation?
I've got a weird mix of, what track is it? Oh bloody hell! It's 2 tracks by 2 completely different artists. One's done a cover of the other, but they've done it exactly the same tempo and a different key. And I've mixed them together into 2 left and right channels, so you can hear exactly the same track, but they're in different keys. And it's some talks. What's that? Oh, what's the track? What's the Talk's famous one? That it was covered by a lady. I'll Google it. Yeah.
How different are the keys, Andrew?
They're weird enough that most people will go, "Oh my god, that sounds awful," but not so different. You know, the woman is singing in a sort of a higher key, but and if you concentrate on that, your left ear, it sounds perfectly fine. If you listen to the right ear, the original, I was thinking I could email you the terrible MP3 that I made, but I'll try and find the tracks and I'll get them to you. I might send them to Matt to share them at some point. I'm sure I did a YouTube. There are bits that they go out of. They do something different, but for the most part, you can start them at the same time, and I'll see what I can do.
Matt, what's your GitHub? Because I'm looking at doing A-frame on Saturday with the STEAMettes. Code Academy they've got a simple one, but I remember you did you do a tutorial on A-frame, or did you just have some A-frame?
I used A-frame for an augmented reality installation for an artist in Margate a year or 2 ago, 2 years ago.
Did you have a simple tutorial or not?
I found some out there. There is a GitHub thing, I think, and I'll see if I'll make sure it's there. It was a little bit gnarly, but after a bit of wiggling around, it was really straightforward. Actually, a couple of wrinkles in it. It's not perfect, but you can get around them.
Yeah, they've done about three months of HTML, JavaScript, and CSS from the Code Club, but that gives it to them as like a little project of a magazine, and it does give you some starting. So I thought I'd try and do it like that, but it's been quite hard to find. There's no simple beginner's guide.
I think, let me have a look at the code. Yeah, I mean, I don't know if you can read this, but this is a really simple one. It's just one marker, and it just puts up one. It's a dancing spaceman, I think, that appears with this marker. But it's literally the lines 7 to 18, so 11 lines of code, really, if you ignore the includes. It took a while to get that and figure out the nuances and so on. But once you've got there,
can you put it in the chat?
Yes, I will.
I might show it to them as like a completed, like pull this up on your phone and.
Well, I haven't actually used it in a couple of years. Hopefully it's still current, but
Yeah.
I would definitely test it before you send it on.
Yeah.
A little while ago, I noticed a couple of people have started their cameras again. I don't know if that's because they wanted to say something.
Yeah, I think Phoebe.
Oh yes, I was just going to say, I think it was at a festival. The XX had an installation where each band member had a screen and was playing their instrument. So depending where you sat in the room, you would experience a different sort of
Okay.
sound.
Which band was that? Sorry.
The XX.
Oh yes.
Is it just one band playing? Sorry.
Yeah, do you know they're quite like shy and retiring, the XX, so the room's in darkness and they're playing their instruments, which is often how they play on stage. And then they had you were in the room and you could stand near them and hear their instrument.
Very cool.
Whoa,
And what was that live?
It was a recording of them. I can't remember if they actually did play at the festival, but it was definitely a kind of digital installation that they contributed.
I'm looking at. I'm trying to find it.
It was a long time ago, maybe more than a decade ago.
I do some. I write music, but I hate performing. I've got like massive performance anxiety, so maybe performing in the dark is the way to go.
Yeah, I have seen them perform in the dark, and yeah, it's really good. Yeah.
Wonderful. I'm trying to find some kind of reference or recording of it online somewhere.
That's for. Sorry, I forgot your name. Muso person.
Joe or Phoebe?
Oh, hang on. Well, hang on. It's My Life. One was Talk Talk, and the other one is No Doubt.
Oh.
So there you go. If you play both those side by side, they kind of start different, but if you sort of time it to the beat, they're exactly the same, but in different keys. And then one of them nips off and does a little bit of what track is it? Something by the Police, Roxanne. It kind of, if you listen to it, it goes Roxanne, the cover. So yeah, have a listen.
Yeah. Well, thanks, Andrew.
That's all right. You're welcome. I have got a mix somewhere, but yeah, I'm not going to be naughty.
I'll try and find a reference to that XX thing. It sounds really intriguing.
I'm a drummer, and we used to perform. I have to say, one of the nicest things is going out with a group of friends and playing. We used to almost ignore the audience and just have a good time. It was like getting paid to have a party every week. It was great. So I implore you to forget your fears. Get out there and sort of ignore the audience almost.
Yeah, good idea. Yeah, it's good advice. And just get paid to have a party.
Yeah. And with that, I might call it a night. I have to say, that was superb, as ever.
Well, thank you very much. Well, the next meetup, as always, it's the last Thursday of every month, and in July that's the 29th.
Okay.
So 7 p.m. again on the 29th of July. Slap bang, really in the middle of holiday season, but we'll march on anyway. So hopefully you'll all be there, and if you do see any social media posts that I put up about it, there'll be I'll put them through the geekery.uk, the website and Instagram and Facebook and Twitter. It's exhausting.
Just tag people like BBC Radio Ken and is it Invicta and any of the sort of local radio stations. Just put it out there because.
Yeah. Well, I have circulated a press release about the co-working desks here in the geekery, because there are 3 spare desks that I'm trying to fill with suitably geeky people. I want to be a little bit exclusive to try and get a good set of 4 people with complementary skill sets and interests, so we can do some cool stuff here. So I've been focused on filling these desks, but after that it'll be kind of refocusing perhaps on more community things like workshops or this Thanet Technology community, which kind of go hand in hand with it all. It'd be really interesting to do some location dependent projects like communicating with Southend across the estuary, or having an autonomous boat to sample the amount of rubbish floating in Margate Harbour compared to Ramsgate and Broadstairs harbours or whatever. I don't know. It just feels like having a community of geeks doing something that is dependent on our environment or our location would be a really lovely thing to do. So maybe that's a direction this group could take in the future.
I've got an app on my phone called what's it called? Rain Alarm. You can see like a radar map of weather coming in, and I like the idea of that as well. So people with it is a bit of a waste of a microBit putting it outside in the rain. However, the idea of see weather turn up and measuring wind by sound or something is pretty cool.
And the Pimoroni Raspberry Pi Enviro Fat, that one, I think there's a plus. That does the air quality and also does the PM particulate matter as a little plug-in thing. So I've got some of those. We might be looking at doing that in Essex.
That's cool.
Just having a look for that page now.
They're currently sold out. Yeah, that one there. There's a
discontinued.
There's a bigger version of it. Enviro Plus, I think.
I did see that.
Is it a BBC sort of
it's Raspberry Pi
zero thing?
Yeah, so it's the size of a Zero, but it will go on a Raspberry Pi.
Okay.
Yeah, so if you just put Enviro hat instead of fat, maybe, or there, there's the pictures of it. Yeah, there we go. So I think they're currently out of stock, but if you look at what it actually does, it's got temperature, light, sound, particulate matter, and then all the chemicals there, and analog gas sensor, and an ADC microphone, light and proximity. And lots of libraries in Python.
There was a guy in America who joined one of our meetings months ago, and we followed each other on social media, and so he pops up every now and again. He's making like a sort of surfboard-sized autonomous boat with lots of water quality sensing things. He's doing it as a business, so he's developing this system to just wander around a river system like a Roomba Hoover does at home, but instead of sucking up the dust, it sucks up data, I suppose, about the quality of the river, which sounds interesting. Yeah, maybe one of the thousands and millions of SUP boards that are coming to Margate could be instrumented and autonomously steered somehow. Don't know.
Dyson have brought out some resources for teachers for air pollution.
Okay.
CO2 and particulates, and it's using sensors with the Arduino.
Interesting.
Yeah, I did offer it to the Royal Harbour Academy because they're doing something on the environment and careers, but I've not heard anything back. But it's something we could offer schools in the area.
Does this look like the thing?
That's the one, yeah. And one of the worksheets is air pollution, the Arduino. Here we are, worksheet 03.
Matt, can you put the link in the chat? That'll
Yeah.
be quite interesting, that one.
I will share all of these links elsewhere as well as the chat if oops. Okay. One thing I did come across, I've been doing IT hubs with a charity, just an hour a month or an hour or two a month, and the charity looks after people who are vulnerable to homelessness, and it's giving them lots of different types of support, including making sure they don't become homeless, but also employability and those kind of things. And after a few sessions, it I was thinking, oh, maybe they want to learn how to program an Arduino or those kind of things, but that's so far away from the reality. But I did find a presentation about essential digital skills that people should have, and some reports have been saying that digital skills that used to be advantageous in the job market, but also for health and well-being, being able to look up stuff on the internet, even that kind of thing. So they used to be advantageous, but because of the pandemic, they during lockdown, they became essential skills, really, and that's not going to go away. So lots more digital skills. The digital divide has grown far faster than anyone was expecting, because of the lockdown and all of these skills changing from being something that gives you a bit of an advantage to actually you need to do these things now. So there's going to be lots of people that could be left behind because of that. Thousands of people in Thanet, maybe. I think that's borne out from this charity, because maybe if I can find the presentation to show you what kind of stuff's in there. And it's pretty simple stuff if you're a geek, I suppose. It goes, like I said when I was talking about 3D printing, it's sort of second nature to me, and it seems blindingly obvious when it really isn't. Everyone is expert about something, and trying to talk to people who aren't expert in it is really difficult, to avoid jargon and not to assume lots of stuff.
Yeah, as an example of that, I'm quite good at running Zoom meetups. I run probably three a week plus. I can do breakout room screen shares. But I went on Teams, had a team meeting with some people, and I think it was like the second team meeting I'd done, and I couldn't find the chat.
Yeah. And I've been trying to spotlight people, but to be honest, I'm not absolutely sure what it does. And I don't mind, because I don't really need to know, but it probably makes people full screen in the gallery view or something like that. But I remember someone telling me that I really should spotlight people or who are speaking, But
yeah, if they're doing a talk, then if I interrupt the talk, normally the picture, you record me for 3 seconds, and you don't really want me interrupting, especially not if I've just banged my laptop as opposed to asking a question. So it does keep it on their face.
That's good to know.
Yeah.
So I'll just so this is just one page of well, there's 9 slides in this PDF-y kind of PowerPoint thing. So things like, you know, I can turn stuff on and use the controls. I remember going to help out a lady and asked her to double click on an icon, and it, after a few sort of round the block kind of conversational dead ends, that's mixing metaphors, I figured out that she'd never used a mouse before, and that wasn't that long ago, maybe 8 or 9 years ago. So not it's very easy to assume a level, really, and there are lots and lots of people falling behind essential skills. I don't know, is that the case with young people in anyone's experience?
I know there have been a few people who haven't joined our meeting because their laptops didn't work. So, as I said, Jitsi was quite bad. And also, I think they were probably using a hotspot on a mobile phone, which ate through lots of bandwidth on their parents' phone. So, you know, there are people who would have come along but couldn't, and because they haven't come along, they've not, you know, done Zoom as much, and they've had problems with their proper schooling. You know, there was the laptop for kids for schoolwork. There's and still is a big push for that, and the government gave out a whole load to schools, but the schools have said we didn't get enough.
I think a stat I read, I might be misremembering it, but I think it was like 9% of kids only have access to one phone at home. There's no other computer, and certainly no other internet access.
The school that I worked at, Pilgrim's Way, was quite a sort of, the families aren't too well off, and so we were a school that really took advantage of that laptops scheme. But I found it incredible how much I've taken for granted, you know, just having these sort of things, and as you say, I think of these as basic skills, but these kids don't know what to do at all.
Yeah, but they are becoming, well, if a basic skill is an essential skill, like buying food, looking after your money, you know, all of those things during lockdown needed a computer quite a lot. So yeah, it's a bit of a desperate need for these essential skills developing out there.
About 5 years ago, so not even pandemic, I spoke to someone who was quite a techie person, would fit right into this meeting, and I said, "Oh, do you want to come along? We're doing whatever we're doing, bring your laptops." And they said, "We don't have laptops." You know, they were quite techie in their family, and they had enough money, but they did everything on their phones and tablets because they knew how to. And you know, that quite surprised me. I think they probably had desktops as well, but they, you know, couldn't. They had a real powerful games desktop with a big graphics card and loads of memory, but they didn't have laptops for going around. So, yeah.
So I do wonder how the geekery can sort of make some kind of inroads into that. And there's been a couple of announcements from Thanet District Council. There's a proposal, it's like £6 million proposal with East Kent colleges to create a digital campus in Margate on the High Street, which would be wonderful. And maybe this little community can somehow get involved with that kind of thing in a similar way to this tech club coming up on the 24th of July in the Margate school. It's just one day kind of pilot to see if it'll work out. But yeah, I'd like to see more of these kind of things and try and get more involved with them. Share a bit of the geekery that I've been taught over the years. Anyway, we'll see.
I think I'm going to actually have to head off. It was really great meeting everyone.
Yeah, thanks for coming, Joe. And I think it does feel like a natural end to this meeting. And it's 20 to 10 now, so quite close to my bedtime. Thank you very much, everyone, for coming and for staying this long as well.
Yeah, can I just say before we go, so this is to John and possibly to Joe if you're still at school. The glove project looks like number 2 is coming out, and there may be some sponsored gloves, so you can buy them for £30, and you buy them with a microBit for £40. But last year you got all the bits apart from the microBit sent to you for free. So I'll certainly let John know, and I'll be putting on social media. And are you interested, Joe? Have you got any young people who might be interested in getting a glove and doing some microBit coding?
Yeah, well, I know certainly the older kids in the school. Yeah, I think they would. The younger children probably wouldn't. It wouldn't.
Yeah, probably like 10, 11 upwards.
Yeah.
It will work quite well. So I'll put. Do you know John?
No, I mean just from this meeting. Hi, John.
Yeah. Okay. Well, I'll probably get Matt to put it in his group, or get John to put it in Matt's group, or whatever. But yeah. So keep an eye out of that. And there'll be 10 lessons, video lessons with little cartoon characters, 10 projects, and then I think that's August. And then in September and October, there's a little competition where you create a project and make some videos about it. So cool. The STEAMettes really enjoyed it last year, and the ones who didn't get a glove are waiting for their glove. They're like, so the moment the thing comes out, I'm gonna let everyone know, go mad on social media, and make sure you get them. There was only 3,000 last year. I think they're looking to get 5,000. I don't know how many gloves they've got, but certainly it's quite cool. And it's music, it's musical. It's got a speaker there with a microBit 1. microBit 2 obviously has a speaker, but then there's little projects where you can do dance and gesture based, and they're all on YouTube currently, so you can go along and look at them now. Awesome. But there's a new one. The new one's going to be about sustainability. They just tweeted today, so let me just put that tweet in, and I'll let you follow.
Yes, please.
On Twitter, you can follow it, and you might be relying on me. Open UK, I think it is. Twitter's just going a bit slow because we're on Zoom.
Thank you very much for this evening. This was the problem I had in front of me. Bracket.
Oh dear.
3D printed, and a scanner that I need to get some better scans out of. So
oh, brilliant.
Yeah, it was a good topic for me.
Definitely. Yeah. Yeah, you'll have to show us more about that.
Yeah, well, I'd like to also follow up. I think there might be some maybe cost savings. I think the bracket costs something like $50 to buy from the manufacturer, but from what you said, it might be a few dollars to print on a machine.
Maybe with a few cents.
Yeah.
Cool. Okay. But I've got that link from Andy, and well, thank you everyone. Feel free to post questions on the social media things for Thanet Technology or the Geekery. And I'm still looking for speakers at the next meetup, the 29th of July. And I hope to see you all there. So thank you very much for your time.
Yep, I should hopefully be there next month as well. So
fantastic.
Thanks everyone. See you all next month.
Yeah. Okay. Thank you, Matt.
Thanks.
Bye.
Andy.
Bye.